I'm curious what you're seeing people do around that whole set of things, around kind of the, like basically customizing, building your own things, combining it with the data that they use for all the rest of the Databricks services.
Yeah, I mean, I'll tell you one of the most surprising thing for me that I saw from Llama is like, okay, you guys put out the bigger ones, they're super smart, and we're like, oh, as a company, we're going to make a lot of revenue on the big models. But the biggest surprising thing I've seen is they distill down and they use the smallest possible, humanly smallest model they can find. So
yeah,
actually,
I mean, the most popular Llama 3 model was the 8 billion.
Yeah, 8 billion.
And we'll build, I mean, we released the Scout and the Maverick ones, right? The 17B experts by, how many of our experts. But I mean, we're working on the big ones. We talked about Behemoth, but we're also working on our internal, I don't know, the temporary code name is Little Llama, but we'll see what we actually end up calling it. But I think that's going to end up being a really popular thing too. Yeah.
Yeah. I think the smaller ones, I mean, the big ones are important because they have the intelligence and people are using Databricks to distill them down. And yeah, you're right. They use RAG. They put the relevant data in there. They use both what they have in the RAG in the vector database and what the bigger models have. But ultimately, their goal is like, hey, so this seems to be kind of like the quality of the frontier I can get with the bigger models on Llama. Now I want to distill down the smallest possible for this particular use case. And the cheaper I can make this, the more important, because I'm going to hit this like, billions of times every day. So like, the smaller I can make it, the better. And yeah, you're right. With distillation, you can, for that particular use case, get the tiny model to have the same intelligence as the biggest ones. Not on everything, but most organizations, they don't want to do everything. They want to like do this thing repetitively again and again. It's just like jobs. Like we don't do everything in a job at work. People are specialized and they do something repeatedly.
Yeah. So do you have a sense on where the sweet spot is on that, or is it shifted over time?
Sweet spot on the size?
Yeah, for the model architectures.
Yeah, I mean, the smaller, the better, honestly. Like, because it's a cost thing. They keep pushing. Like, I think the smaller you can. So the question is just how much can we compress the AI down? So a lot of organizations are thinking like this. Okay, I have this repetitive task. What's the frontier SOTA, so state of the art? Okay, and now do that as cheap as possible. Who can do this, or can I distill the cheapest possible? And I don't think there's like a, oh, we don't want to go below 1 billion parameters or so on. No, if you go even further. We have a lot of customers that are doing coding, and for coding, you want to have, as you're typing, you want it to code ahead and write ahead for you. There, you want that latency is super important. So even a few billion parameters might be too big, you want it to quickly do autocomplete, like milliseconds count. So I think there's going to be a continued race for like, okay, frontier big smart models, which you guys are doing, and then I'm looking forward to the, what did you say, small llama?
Yeah, little llama.
Little llama, yeah, little llama. Looking forward to little llama. I hope it's really small. And tiny llama and mini llama and whatnot.
There's always a smaller llama.
Yeah, exactly.
Yeah.